Before we jump into the notes for today, let's quick review our sig figs from the previous day. So the first ones that I have up here, I want to review how many sig figs there are. So in this first number right here, we have 4 sig figs because we've got these non-zero numbers here. That's a sandwich zero, so that counts. That 0 does not count because it's a trailing 0 with no decimal. This one right here, we have 1 sig fig because leading zeros never count. So the only one we have here is the 3. So whenever you have zeros in front of a number, you're never going to count them. This number, we have 5. We've got our sandwich 0 and our non-zeros. These zeros count because they're trailing zeros with a decimal point. So unlike in the previous one where there wasn't a decimal point, since this one has 1, those zeros count. And the final example over here is going to have 5 sig figs as well. We've got 1, 2, 3, 4, 5. This trailing 0 counts because of the decimal point up here. So even though it's like way after the decimal point, it still counts. These leading zeros don't count because leading zeros never count. So the big thing that you are going to have to do with sig figs is to be able to do calculations with them. So on this first example here, we are adding. And if you remember, the rule for adding is all about where the estimated digit is. So in 12.5, the estimated digit is the 5, so it's in the 10ths place. In 6.72, the estimated digit is in the 2, so it is in the 100th place. So the first thing you should always do with this is just do the math. So when you type this into your calculator, 12.5 plus 6.72, you get 19.22. That's what you should do first. Then you should go back to the beginning. This estimated digit was in the 10ths. This one was in the 100ths. So your final estimated digit and your final answer should be to the 10ths place. So we should shave off this 2 to have our final answer of 19.2 milliliters. Make sure you've got your unit on there. For the next one, we have subtracting. So adding and subtracting are going to use the same rule. So in 121, our estimated digit is the 1, so in the 1s place. 13.7, our estimated digit is the 7 in the 10ths place. So again, the first thing you should do is just do the math. So 121 minus 13.7 comes out to be 107.3. Okay. Then we go back to the beginning. We had our estimated digit in the 1s place here, the 10ths place here. So our final answer should have its estimated digit in the 1s place. So shave off the 3 for a final answer of 107 grams. All right, now the next two are multiplication and division, which is a totally different rule. For multiplication and division, it's all about how many sig figs there are. So for here, we've got 12.5, which has 3 sig figs, and 3.6, which has 2. So when you type into your calculator 12.5 times 3.6, you get 45. And your final answer should have however many sig figs as the one with the least amount. So we've got 3 and 2, so 2 wins. So our final answer already has 2 sig figs, so there's nothing to change with this one. And since you've got centimeters times centimeters, you would have centimeters squared as your final answer. For this last one, multiplying and dividing have the same rule. So again, we're going to count the number of sig figs. So 12 has 2, 1.50 has 3. So the first thing, again, you should do is just do the math. So when I type in 12 divided by 1.50, my calculator spits out an 8. Going back to the beginning, we have 2 sig figs and 3 sig figs. So at the end of the day, I should have 2. But right now, notice how I only have 1. So what I need to do is I need to add a sig fig by writing 8.0. So I had 2 and I had 3 for sig figs, so I should have 2 in my final answer, so you can add sig figs if you need to. The unit for this one then, I've got grams divided by milliliters. So it's going to be 8.0 grams divided by milliliters, or grams per milliliter would be my final answer there. So this is kind of a quick review on everything we talked about as far as sig figs the previous day. There are a couple of instances where weird sig figs happen. Examples like this you wouldn't necessarily see on a quiz or on a test, but you might see them in real life when we're doing labs or you're collecting your own data. So I don't know if you can hear my cat, but she's about to be fed, so she's upset. So for this one, 7,030,000 to 2 sig figs. So currently, this number has 3, okay? The 7, the sandwich 0, and the 3. So if I want to make this go to 2, you would keep the 7, and then you'd go to 0, but then when you get rid of the 3, and you can't round up because it's not higher than 5, you're left with 7 million, which only has 1 sig fig. So this one doesn't have a really nice in-between to ensure that you have 2. So what we can do is we can use scientific notation in order to do that. So what I'm going to do, if I'd like to put 7 million in scientific notation, I would take my decimal point and hop it 1, 2, 3, 4, 5, 6. So how I'm going to write this is I'm going to go 7.0 times 10 to the 6. And this has 2 sig figs. Because 7.0 has 2, right? Because of the decimal place, that 0 counts. And then 10 to the 6 gets it to that 7 million place. So kind of weird. Again, not going to really see it on a quiz or on a test, but something you should know how to do just in case an example like that ever comes up. The beaker has another example with this as well. So notice how our increments are going up by 10. So we've got 10, 20, 30. So it's in between the 20 and the 30, so I know it's at least 20, right? And at least for me, it looks like it's kind of like right on the money, like right on the 20. So I would write 20. And then this is measured in milliliters. It's not written down. So then milliliters. But here's the problem with this number. If I were to tell somebody else, hey, I have 20 milliliters of water, and I wrote down this number, they would assume my estimated digit was the 2, because this number only has 1 sig fig. But in actuality, I know the 2, because this went up by tens. I estimated the 0. And since your estimated digit has to be a sig fig, how you handle this, I know this seems weird, you would write 20 milliliters. Because that decimal point makes that 0 significant, because trailing zeros with a sig fig count. So now this number has 2 sig figs. So now it looks like my 0 is estimated, which is exactly what it was in this case. So again, nothing you'd really see on a quiz or a test, but something that you might deal with in real life, and this is how you would handle it. All right, so now on to the dimensional analysis part. So dimensional analysis is all about conversions, so the ability to convert from one thing to the next. In this unit, we're specifically going to be converting within the metric system. So to do that, you need to know the different prefixes within the metric system. So we have kilo, hecto, deca. This is the base units, okay? So base. So meters, liters, grams, and then deci, centi, and milli. So how this works is you could say like kilo meters, hecto meters, deca meters, or you could say deciliters or centiliters, milligrams, etc. So these go in front of these main words. This right here, you will get on every quiz and test, so that's not something that you have to memorize. Just for the sake of memorizing though, because it might make your life a little bit easier, I have a little thing that you can use. King Henry dances, many dances come Monday. That's how I remember the order of the prefixes. One thing I want you to note specifically notice how deca is a capital D and deci is a lowercase d. Other than that, it's pretty self-explanatory. So using these prefixes, using this order, we are able to convert within the metric system, because between every single one of these prefixes, it's all a power of 10. So there's 10 milli whatever, so let's do meters. 10 millimeters in 1 centimeter, 10 centimeters in 1 decimeter, 10 decimeters in 1 meter, which ultimately means there's 10 101,000 millimeters in 1 meter. So all of these hops are a power of 10. So here's an example of how this would play out. So your kind of typical question that you would be asked would be, how many centigrams are in 2.3 kilograms? So how many of this and how many of that? So the first step that you always need to do is you need to take the number I've given you, so 2.3 kilograms, always take the number I give you and put it over 1 like you see here. So 2.3 kg, 2.3 kilograms divided by 1, because any number divided by 1 is just itself, so you're not changing it. You're just setting up your fraction. The next thing you need to do is whatever unit you have on top, you are going to put that unit on the bottom. Because as we know from math, when you have something on the top and on the bottom, they cancel out. So kilograms will cancel out, which then leaves you with the unit you're looking for on the top. So you put kilograms on the top here because that's what you start off with. Then you put on the bottom, cancel out. Then you put what you want on the top, which is centigrams. That's what you're left with, and that's what your final answer is in. The thing you need to figure out is the numbers here. So in order to do that, you are going to use the King Henry Dances, Mini Dances Come Monday up here. So there's lots of ways to do this. If you have a way that you're more comfortable with, by all means use it. This is what I do. I always want to figure out how many small are in one big. So how many small in one big? Smaller numbers are on this side and big numbers are on this side. So how many small in one big? In this problem, I have centigrams and kilograms. Centigrams and kilograms. And how this works, since every single one of these is a power of 10, every single hop you can basically add a 0. So what I mean by that is I could go 10, 100, 1,000, 10,000, 100,000. So what I know from that is there are 100,000 centigrams in 1 kilogram. How many small in 1 big? And since I put kilograms on the bottom and centigrams on the top, and it's 100,000 centigrams in 1 kilogram, I put the 100,000 on top. Then you just do the math, boom, you get your answer. As far as sig figs go though, because remember, sig figs are here now, whenever you do a calculation, you need to take into account the sig figs. But here's where it gets a little interesting. So notice for 2.3, there are 1, 2 sig figs. But you might have noticed how these numbers have 1 sig fig. But all conversions are exact numbers. If you remember from yesterday, we only use sig figs for measured numbers because there are exactly 100,000 centigrams in a kilogram. You technically could count that if you wanted to. So this relationship is exact, so we do not include it for sig figs. So however many I have at the beginning, which is 2, is what I should have at the end here. Let's go ahead and work through another example together. All right, so here's one that's not started for you, okay? So again, here's how your question would be phrased. How many deciliters are in 3,693 milliliters? Step 1, take this number that I've given you, and put it over 1. So take exactly what's written. So 3,693 milliliters. Okay? And then you need to write that over 1. Because anything divided by 1 is just itself. Okay? That's step 1. Step 2, take whatever unit you have up here and put it on the bottom. Okay, because if something's on the top and something's on the bottom, they cancel out. That's step 2. Step 3, take what you're looking for, which in this case is deciliters, and put that on the top. So now my milliliters cancel out, and then I convert to deciliters. Last step, you need to figure out the relationship between these. So like I said, I like to know how many small is in one big. So I have to come up here. So I'm dealing with milliliters, which is right here, and deciliters, which is right here. So milliliters are smaller. So I'm going to start here. And remember, every single hop is a power of 10. So I'm going to go 10, 100, 1,000, 10,000. Another way to think about it, so 10, 100, 1,000, 10,000. Do you notice how I added a 0 every single time? Okay. So again, I like to figure out how many small and one big. So what does that mean? There are 10,000 milliliters small in 1 deciliter big. So 10,000 milliliters in 1 deciliter. So one question that I get asked a lot is, so how do I know where to put this number? Do I put 10,000 on the top or the bottom? Well, do you see how it's 10,000 milliliters? So I'm going to put the 10,000 milliliters where I have milliliters. So I'm going to put it on the bottom. So now, milliliters cancel out. I'm left with deciliters. Okay, so those are gone. So now you just do the math. So 3,693 divided by 10,000, which gets you 0.3693 deciliters. So check your sig figs, okay, because now we got to check them every single time. Remember, these relationships are exact, so you don't worry about them. So you just need to go to the beginning. So I see 1, 2, 3, 4. At the end, I see 1, 2, 3, 4. And that's that. So what I want you to do is I want you to go to your notes and I want you to try to solve this one by yourself. Then come back to the video and check your answer. So pause right now. When you come back and push play, the answer will be up on the screen. So push pause. All right, here you go. So your final answer should be 2.45 meters. So first thing I did, took the number I had, put it over 1. 245 centimeters over 1. Then take this unit, throw it on the bottom, because then it'll cancel out. Take the unit you want, which was meters, put it on top. Next thing, figure out the relationship. So you had centimeters and meters. So from small to big, it was 10, 100. So 100 centimeters in 1 meter. Put the 100 on the bottom, solve, you're good to go. Then looking at sig figs, 1, 2, 3, 1, 2, 3, because these are exact, ignore them. So if you can do this in your head, or if you can kind of figure this out on your own without all of the work, I still need you to show the work, because we're going to have some where you won't be able to just figure it out on your own. Along with once we start adding chemistry to dimensional analysis, you're going to need to get into the habit of showing your work anyways. So even if you can do this, always show your work. So that was kind of level 1 dimensional analysis. And now I'm going to give you 2 examples where it's level 2 dimensional analysis. So for level 2, if you can notice, what we are going to be doing is we are going to be converting from squared to squared, and we're also able to convert from cubed to cubed. So in this question, how many centimeters squared are, you guys, my cats are fighting, I'm sorry. All right, so we've got how many centimeters squared are in 23 meters squared. So we start off the same way. Take what I gave you, put it over 1. So 23 meters squared over 1, same start. But remember, meters squared technically means meters times meters, right? In other words, 2 meters. So if you have meters squared on the bottom, in order to fully cancel that out, you need to have meters on the bottom twice. And then if you're looking for centimeters squared, which is technically centimeters times centimeters, you need centimeters on the top twice. Other than that, though, you do everything the exact same. So you put the units on there, you just do it multiple times. You still figure out the relationship. So centi and meters, you've got 10, 100. So that's where the 100 is coming from. So then you're going to go 23 times 100 times 100, which gives you this final answer of 230,000 centimeters squared. Check your sig figs. 1, 2, 1, 2, good to go. These are exact, so therefore we do not count them. So let's work through one together, okay? So again, first things first, take what I give you, put it over 1. So we've got 1,468,000 millimeters cubed. So now the last one was squared, this one is cubed. So if you have millimeters cubed, what you need to do is have millimeters on the bottom 3 times. Then the question is asking for how many meters cubed. So you're going to put meters on the top 3 times. After that, the setup is the same. So we're dealing with millimeters and meters, okay? How many small and a big? So we've got 10, 100, 1,000. 10, 100, 1,000. And how many small and big? So that's 1,000 millimeters in 1 meter, small to big. So when it comes to entering in and up here, I'm going to put the 1,000 millimeters, I'm going to put the 1,000 on the bottom. And the ones on top. So then for the math, what I'm going to do is I'm going to take 1,468,000 divided by 1,000, divided by 1,000, divided by 1,000, which spits out the answer 0.001468 millimeters, meters cubed. Check your sig figs. 1, 2, 3, 4. Trailing zeros don't count because there's no decimal. 1, 2, 3, 4. Leading zeros don't count ever. So just like before, go onto the slide. Try this one all on your own. So pause the video, try this one on your own, and then once you feel like you've got it, come back and check and see if you're right. All right, here we go. So this spits out a very, very small number, okay? So what we have here is, again, take the number I gave you, put it over 1. Oh, that got weird looking. Okay, so that's supposed to say 495,948,000, okay? Centimeters cubed. So it's cubed, so you need to put centimeters on the bottom 3 times. You want kilometers cubed, put kilometer on the top 3 times. Okay, then how many small are in a big? So we had 10, 100, 1,000, 10,000, 100,000. So that's why we had it on here 3 times. So you kind of have 2 options to express your answer. So you could express it this way, or if you wanted to, you could have expressed it in scientific notation as well, in order to save yourself some space. Checking sig figs, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 in either option. And here is tier 3 dimensional analysis. This is as tricky as it's going to get. So I call these the double-decker examples. So kind of in the sig fig review that we had from before, we are going to be dealing with some cases where your unit actually has 2 components to it. So kind of think of like miles per hour or meters per second, or kilograms per liter. So when you have 2 units in a unit and you want to convert it, you actually do need to convert both. So in our example here, we have how many grams per milliliter are in 43 kilograms per liter. So what we do here is we're going to do 2 conversions, but in the same problem. We're going to convert kilograms to grams, or top to top. And then we're going to convert liters to milliliters, or bottom to bottom. Okay? So first step is always the same. Take what I gave you, put it over 1. But notice how I did 43 kilograms per liter. So I put the kilograms on the top and the liters on the bottom. And then what you can kind of do is just focus on the top unit right now. So pretend the liters isn't even there. So kind of like hone in on the red on the page. So you've got kilograms on the top. Put kilograms on the bottom like we've always done. Find kilograms and grams up here. Okay, so grams is small, kilograms is big. 10, 100, 1,000. So 1,000 grams in a kilogram. So since it's 1,000 grams, we put the 1,000 where the grams was. Done. So kilograms cancels out, good to go. After you convert the top to the top, then you basically ignore the top, pretend it's not there, and now hone in on the blue. So we have liters on the bottom, and I would like to convert liters to milliliters. But we kind of do it opposite. So since we have liters on the bottom and we want to get rid of it, I put liters on the top, because that way the liters will cancel out. I wanted to go from liters to milliliters, so I've got milliliters and liters. Small to big, 10, 100, 1,000. So 1,000 milliliters in 1 liter. And in this case, I put the 1,000 on the bottom because that's where milliliters was. Okay? So my liters cancel out, my kilograms cancel out, so what I'm left with is grams per milliliter, which, hey, is exactly what I wanted. So you go through and do the math, 43 times 1,000 divided by 1,000, you get 43 grams per milliliter. Grams per milliliter. Check your sig figs, 1, 2, 1, 2, good to go. Ignore these, they are all exact. So you're basically doing 2 conversions in 1 problem in this example. All right, so here's another double-decker example. Okay, so for this one, we want to know how many meters per second are in 88 kilometers per hour. So first things first, take the number I gave you, put it over 1. So I'm going to do 88 kilometers per hour. So kilometers on the top, hours on the bottom. And then you can throw a 1 down there if you want to. You don't have to, because the 1 doesn't really mean anything, okay? So that's your initial setup. Remember, how this works is you're going to convert top to top. So I'm converting the kilometers to the new top unit of meters. That's my first conversion. And then my second conversion is converting hours to my new bottom unit, which is seconds. So first thing, just focus on what I circled in red. Okay, so we're just going to focus on the kilometers. So kilometers on top, throw kilometers on the bottom. That way they cancel out. I want to go from kilometers to meters, so I'm going to put meters on top. Come up to my number line, I've got meters and kilometers. So I've got 10, 100, 1,000. So 1,000 meters in 1 kilometer. So I'm throwing 1,000 on the top, 1 kilometer on the bottom. My kilometers cancel out then, good. Now I'm going to ignore what I did in red and now focus on blue from hours to seconds. Notice how I have hours on the bottom right now? So I need to throw hours on the top. So you could do this one of two ways. You could convert straight from hours to seconds. I'm going to do it in 2 steps though. So what I'm going to do is I'm going to convert my hours to minutes first. Okay, so now my hours cancel out. But remember, I actually wanted seconds. So then I'm going to throw minutes on the top and seconds on the bottom. My minutes cancel out, and then all that I'm left with is meters per second, which is what I wanted. Don't forget your numbers, okay? For hours and minutes and seconds, that just kind of needs to be in your head. And we know that there are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. So then you're going to go through and do the math. So you're going to go 88 times 1,000 divided by 60 divided by 60. And when you do that, it spits out, so here I'm going to just cross this out. It spits out 24.444, okay? But we did a calculation, so we need to check our sig fix. So 88 has 2, okay? This is exact. There's exactly 1,000 meters in a kilometer. You could count that. Don't count it. There's exactly 60 minutes in an hour. You could count that. Exactly 60 seconds in a minute. You could count that. So at the end of the day, this wins. I should have 2 sig figs. So 1, 2, shave off the rest. So my final answer is going to be 24 meters per second. All right, you tried this last one on your own, just like we've done before. One thing that you need to note though, okay, we've got one new special relationship here that isn't on the number line itself. And that is that 1 milliliter is equal to 1 centimeter cubed, which is equal to 1 cc. If any of you like doctor shows, like Grey's Anatomy, you'll see that they shout all the time, like, get me 50 cc's of this whatever stat. Cc actually stands for cubic centimeters. And a cubic centimeter is equal to a milliliter. So when they're saying get me 50 cc stat, what they're actually saying is get me 50 milliliters stat. But obviously trying to say milliliter really fast or even cubic centimeter really fast is annoying. So for the sake of ease, they say cc instead. So all of these are equal to each other. So see if you can figure out how you would use this relationship in trying to do this answer right here, and then come back and check. All right, and here's your final answer. So notice how I converted kilograms to grams, centimeters cubed to milliliters. So top to top, bottom to bottom. So kilograms on the top, threw it on the bottom. That way they cancel out. Then I'm left with just grams on the top. For the second one, I had centimeters cubed on the bottom, so I threw it on the top to cancel it out. So then I was just left with grams per milliliter. Notice though, since all of these guys are the same, all you have to do is write 1 over 1. So it's not really much of a conversion since they all mean the same thing, but that's how you would technically write it out. 2 sig figs here, 2 sig figs here, done. So this is dimensional analysis. This is as tricky or as difficult as it's going to get. You can work on assignment 4.3. You could also start looking at 4.42. It's got some trickier dimensional analysis on that as well.